So let me write it this way. So we have this wave equation. It's semi-infinite, and time is also semi-infinite. We have initial position and initial velocity. From the equation and the uh, initial conditions, we have this kind of solution where phi and psi are given like this. So we have then the solution uxt, which is just uh, phi x minus ct plus psi x plus ct, and that is equal to so 1 over 2 uh, f of x minus ct plus f of x plus ct, and then plus 1 over 2 c times x minus ct. So when you add these two, right, you get, okay. Now here I write x minus, no, here x minus ct. So this becomes from x0 to x minus ct, and this is from x0 to x plus ct. Uh, if I, so this is minus, if I make it plus, then the boundaries of the integration will be reversed. So we will get integral from x minus c2 to x0, and then you have this. So when you add these two integrals, you will get this. And g tau d tau. Değil mi? Yani artıya dönecek. Burası da şey olacak. X minus ct'den x 0'ya olacak. Okay, so this is what we get. And then we do what? Now, of course, here, our function g is only defined for positive values. Therefore, when this number is negative, this doesn't make sense. So uxt is equal to this gadget, provided that x minus ct is positive. Otherwise, this doesn't make sense. What happens for negative values? For x minus ct negative, we use the boundary condition u0t equals 0. To obtain şimdi onu yerine koyarsak burada ne elde ederiz? 0 equals u0t. X yerine 0 yazarsak 1 bölü 2 eksi ct artı ct artı 1 bölü 2c eksi ct artı ct g tau d tau. Ee, Bu da ne verir? Aa, ha, aa, Bir dakika. Aa, Buradan şunu sanırım yazabiliriz. Ee, O biraz anlamsız gibi duruyor. Kim? Yani şöyle bir şey yapmış anladığım kadarıyla. Ee, Buradan böyle yapıyor. Bakayım. Aa, Şöyle yapıyor. Ee, Boundary condition is this, and that gives us no, this is u, and that gives us from this 0 minus xt plus psi 0 plus ct, sorry. So pi minus ct is just psi ct with a negative sign. So this means what? For the negative values, this function should be defined as this one. In fact, this wasn't defined for negative values, but to make things work nicely, for negative values, one should define this function as this one. And then, okay, so this means pi x minus ct, if x minus ct is negative, this should be just minus psi c x minus ct. Pardon, bunu eksiyle çarpacağız. Ct minus x. Yes, and that is equal to, so psi, where is psi? Psi was this. Right, so it is 1/2 f of ct minus x plus 1/2 c, but we have minus sign, so minus x0 to ct minus x g tau d tau. Okay. Buradan da şöyle yazabiliriz. Uxt is then which is pi x minus ct plus psi x plus ct. So instead of pi x minus ct, assuming x minus ct is negative, okay? So for negative values, it is this expression. So it is minus 1/2 f of ct minus x minus 1/2 c x0 to ct minus x g tau d tau plus psi x plus ct, and it is just 1/2 f of x plus ct plus 1/2 c, and then x0 to x, which is just x plus ct g tau d tau. Peki o zaman şunu elde ediyoruz. Şunu bir daha yazayım. 1/2 f x plus ct minus ct minus x plus 1/2 c. This expression x0 to this minus, so this is minus, if I make this plus, then this 2 will be interchanged. So I will have 1 over 2 c from x minus ct minus x to x0, and then x0 to this. So okay, ct minus x to x plus ct g tau d tau. Okay. O zaman genel çözümü şöyle yazabiliriz. So u xt, hence the solution is u xt for positive values of x minus ct, right? For positive values x minus ct, this is the solution. So 1 over 2 fx minus ct plus fx plus ct plus 1 over 2c, and then x minus ct to x plus ct g tau d tau. So this is true if x minus ct is positive, and for negative values it is this expression over here. So 1 over 2 fx plus ct minus f ct minus x plus 1 over 2c, and then okay, I don't need this, ct minus x, x plus ct g tau d tau. This is when x minus ct is negative, or ct minus x is positive. Yani dolayısıyla bu sınır koşulu yine pozitif. Okay. Döndürmüştüm sanki, dönmemişim. Okay, so this is the general solution. Yani buradaki temel şey şu. This initial condition dictates us that for negative values, psi should be defined like this, okay? This wasn't defined for negative values, so we define it this way. And then, solution makes sense. Let's see now one example. Find the solution of the initial boundary value problem. So it's a wave equation with okay. trivial boundary condition, and initial position is sine x, and initial velocity is 0. So initial position is positive sine x. I mean absolute value of sine x. So it is like this. Okay. So it is this wave. And this end is kept at this point. So it is always 0. Okay. So what is the solution then? Okay. Now f of x is just absolute value of sine x, and g of x is just 0. So we just write down the solution xt. There is no g term, right? So there is no g term. We will only have f. Yazalım. So 1 over 2 f x minus ct f x plus ct, if x minus ct is positive, and 1 over 2 f x plus ct minus f ct minus x, evet, bir yazacağız. X minus ct is negative. Evet, c'de 1 değil mi? C equals 1. So we have what? 1 over 2 f de sinüs değil mi? O zaman bu nedir? Sinüs x eksi t artı sinüs x artı t mutlak değer x eksi t pozitifse, çok yaşa, 1 bölü 2 sinüs x artı t eksi sinüs x, no, t eksi x. Burada da x eksi t negatifse. Dolayısıyla çözüm bu. Muhtemelen yazılımlar vardır. Hani bunların grafiklerini çizen. Ee, Şimdi t'yi değiştirdikçe hani hareket ediyor. O yüzden belki öyle hareketli grafikler vardır. Online şeylerde. Değil mi? Yani her t için bu grafiği çizeceksiniz. Dolayısıyla grafik hareket edecek. Yani o da dalganın hareketini söylüyor. Right? So you graph this for all t. So it becomes a movie, right? And you see how the wave travels. Uh, there should be some online programs, I guess, which does this. Yoksa da siz yapabilirsiniz bence bir tane. Okay. The finite vibrating uh, string problem. Ara sıra kameraya bakıyorum ya hani doğru yerde mi diye. O tabii şeyde gözüküyor. Birisi şey diye yorum yazmış. Hocam gizli kamera mı var? Hani ni- niye bakıyorsunuz diye. So this time we have again the same equation, but the string is finite. So it's a guitar string. Uh, we have first trivial conditions at the boundaries, like guitar string, and uh, we have initial position and initial uh, velocity. Right? You may just, for example, pull the string and then release it, and then it will start vibrating, or you may hit the string, right? So you give an initial velocity. So both of them are, possible. How we will solve this? So we will solve this using separation of variables. Uh, using the method of separation of variables, like the heat equation. So we assume, let me, okay, follow the steps. Step one is we try solutions of the following form: a function of x times a function of t, right? We assume that the variables are separated in product form like this, and then we just plug this into the equation. So we just take derivatives. What is, for example, u sub x? It is just x prime times t. What is u sub xx? Well, that is prime times t. Similarly, u sub t is just x times t prime, and u sub tt is just x times t double prime, right? And then uh, we just plug this into the equation. Let's see what we get. Okay, we plug them into the equation. Uh, so that's the second step. No, first step. Plug them. U sub tt is equal to c squared u sub xx. So we will get what? X times t double prime is equal to c squared times x double prime times t. And then from this, we can write it as like this. So And as usual, we make the following argument. This is a function of t only, because t is a function of t. This is a function of x only, and they are equal to each other. So no matter how you choose, how you change t or x, this ratios doesn't change, because when you change t, this might change, but this doesn't change. Therefore, this shouldn't change. And the same way, as you change x but keep t constant, this will not change. This will change, but since they are equal, they cannot. This cannot change either. So both of them should be equal to a constant, and that constant is common. Let's call that constant. Uh, okay. Lambda diyeyim. Okay. Now from this we get what? From this we get the following equations. X double prime minus lambda x is equal to 0, and uh, t double prime minus lambda times c squared t equals 0. This time, both of them are second order equations. In the heat equation, this was second order, but this was first order. How can we solve this? Let me see. İlk önce şeyi yapıyor. İyi, ben de öyle yapayım. Okay. So step 2. Well, let's start with this one. And we have, of course, yok şöyle yapalım. Case'lere ayırıp yapalım. Şöyle. Yani bunu yazacağım da. Bir de initial condition ve boundary condition'lara da bakalım. Initial condition'lar ve boundary condition'lar ne olacak? 0 t equals 0. So this is x of 0, and then t of t is 0. So if this is not 0, right? If this is not 0, then this becomes the 0 function. Therefore, the solution becomes the 0 function. So if x of 0 is not 0, then uxt, which is x of x and t of t, would be 0, because since this is not 0, this function should be 0. And we would get the 0 solution, but that's not interesting, which is the trivial solution. And u equals 0, of course, is a solution, but it is useless. So let's assume x of 0 equals 0. So we have this condition. What else do we have? We have also the other condition. Onu da şuraya yazayım. Similarly, u lt equals 0 implies x of L is 0. Değil mi? Aynı şekilde bu var elimizde. Şimdi o zaman bakalım case'lerimiz var. Case 1 K'nın pardon lambda'nın pozitif oldu. Zamanım var mı? If this is the case, you see we have this equation. So we have characteristic equation r squared minus lambda is equal to 0. R squared is lambda, but lambda is positive. Therefore, R is plus minus square root of lambda. Therefore, x of x is just C1 times e to the power square root of lambda x plus C2 e to the power this. But if you plug these conditions, x of 0 equals 0, and you get what? You get C1 plus C2 is 0. We had done this computation before. If you plug this one equal to 0, you get C1 times e to the power square root of L lambda times L plus C2 e to the power minus square root of L times square root of lambda times L is 0. And here, of course, we know that C2 is just minus C1. If you plug it here, you get C1 in C1 parentheses e to the power lambda times L minus 1 over e to the power lambda L equals 0. Well, this number is lambda is positive, L is positive. Therefore, this is a positive number. No, not only positive, but this is larger than 1, right? E to the power, a positive number is always larger than 1. Therefore, this is strictly less than 1. So this is larger than 1, this is less than 1. Therefore, this number cannot be 0. And this implies C1 is 0. Right? Since this number is not 0, but the product is 0, C1 should be 0. And then, of course, this gives C2 equals 0. Therefore, UXT would be just 0. You get the 0 solution. So we just eliminate this. And then we pass to the case lambda is equal to 0. Yes, let's give a break. After the break, I'll continue.